Hello, this is an introduction to Pandas and machine learning. So before I get started into the Pandas and machine learning, I just wanted to talk about the software that I'm using. And so what you're looking at right now is a Jupyter Notebook. So a Jupyter Notebook is basically just a way to display and run Python code, although it does do other things, but we won't get into that in this video. The reason why we're using this is because it's a pretty popular tool in the data science community that allow chunks of code to run in cells. So as you can see, this is a cell and this is a cell. So this is useful because you can just run cells one time and then all the outputs will be used in the rest of your code. This is especially helpful if a cell takes a really long time to run and you only want to have to run that one time, so that way you can tinker with the rest of your code without taking up a lot of your time. So for example, if I want to load all these packages, then I can just run it once and I'll be able to use that in the rest of my code. The next library that we're going to be using is Pandas. So Pandas is a library that allows you to easily work with data and visualize it in like a table format. And so this is really useful, especially for other projects, because it allows you to convert data from a CSV file, or commonly known as like an Excel file, into your Python code, so that way you can actually work with it and visualize it and do machine learning with it. And so while we won't go deep into Pandas functionality in this tutorial, I just thought it would be nice to introduce it. And then the last library that we're going to be using is Scikit-learn, and this is what we're going to be using for the actual machine learning. So this library is really common and it has lots of different types of classifiers that are pre-made and very easy to implement. And it has a lot of documentation, so this is what we'll be using. And so the first step is importing all the libraries. So this is everything that we're going to use. As you can see, the Pandas library is imported as PD. So if you see that later in the code, you know that it's just Pandas. So the dataset that we're going to be working with today is the iris dataset. So this dataset consists of 150 different types of iris flowers, and each of them belong to one of three categories as seen here. And so we're given a few things about the data, like the sepal length, width, petal length, and width of each flower, and the goal eventually is to be able to classify each flower into like one of the three categories. And if you want more information, it can be found online or here in the documentation. So first we're just going to load the data set in this first line, and then as you can see, the x variable is going to be the data and the y variable is going to be the label, or the which is one of these three categories. And this is a very common practice in machine learning for x to be the data and for y to be the label. So if you see that elsewhere, just know that it's common practice. So let's take a look at the data before we do anything, just to see what we're working with. So as is, you can see that there are 4 columns for each row, and each column would stand for the sepal length, the width, petal length, and petal width, and then each row would stand for a different flower. And so that is the x variable. And then the y variable down here is the corresponding target value. So 0 would be setosa and so on and so forth. And so this 0 corresponds to the first flower up here, while the last two corresponds to this last flower here. So as you can see, this isn't very visually appealing to look at, and you can imagine that it would be pretty hard to work with as everything is in a NumPy array. So it might not be easy to reference specific values. So this is why we're going to convert things to pandas, a data frame. So as you can see, in this first line of code, we're converting x to a pandas data frame of x and y to a pandas data frame of y, using just a simple data frame function. And next, we're just labeling the columns of the x table so you can just see it easy. And then we're going to print out the first 5 values of x. So as you can see, this is much easier to work with compared to this first NumPy array that we're given. And then some added functionality of pandas, just to show you, is that you can easily reference columns by just using the column name. So here we'll show you the stable width column. So as you can see, all these values correspond to these values in stable width. Alright, so next we're going to get into the machine learning. So before we start, let's just go into what is machine learning. A pretty broad definition is that machine learning is an aspect of computer science and increasingly statistics that uses algorithms that get better with experience in order to achieve a goal. So in this case, where we have this data and the goal that we want to achieve is that we want to predict the category that it belongs to. And there are 2 main types of machine learning. Obviously there are more, but these are 2 big types, supervised and unsupervised. The only difference between the 2 is that supervised learning algorithms take advantage of that data that have labels, while unsupervised machine learning models can work even if the data doesn't have any labels. And hopefully this will become clear as we move on. And so next, I would like to go over a few steps to implement machine learning. And while this is by no means a comprehensive list that will work with every dataset, this might be a good starting point for beginners. So the first step is data pre-processing. This could include getting rid of rows that have missing values or turning text into numbers, because most machine learning algorithms can't work with text. Fortunately, we don't have to do that for the iris dataset, so we won't really be covering it in this video. The next part is feature engineering. And again, we won't have to cover this in this video because the iris dataset is pretty simple, but it might be something that you want to look into if you want to continue doing more complex machine learning algorithms or use a different dataset. So in this video, we'll start by splitting the data into train and test data. The reason that we need to do this is because a machine learning model is supposed to be generalized. So in this case, we want to be able to predict in the future any iris flower what category it will be. So in order to actually test to see the validity of our data, we'll have to use a certain set of data that it hasn't been trained with. Otherwise, that wouldn't be prediction, it would just be memorization. So we'll use the test data to test the validity, and we'll use the train data to actually train the machine learning classifier. Next step is to actually train the classifier on the training data, and then we'll use that classifier to predict the test data, and then we'll see how good it is by checking the accuracy. So splitting the data into train and test data is very easy with scikit-learn's train test split function. So into the function you pass the x and y values, which we defined up here, and you also say the test size. So we want 20% of the data to be test data and 80% will become train data, and the random state, which isn't very important. So as you can see, we split the data 80% and 20%. As you can see in X train, there are 120 rows, which is 80% of 150. So if we want to look at this data, we'll just look at the first 5 values. And as you can see, it's been split. and here are the corresponding y values. So you can see that 126 lines up with 126, 23 and 23, so on and so forth. So let's get into the first machine learning classifier that we're going to use today. A support vector machine is one of the most basic models, and this is done by just separating the data by using a line or a hyperplane. So as you can see in this graph, there are triangles and squares, and to a human it's very easy to split this data because they look very different. But for a machine, we're going to have it draw a line that will make it separate the data into the respective groups. And this can be done in 2 dimensions, but you can also imagine it being done in 3 dimensions or n dimensions, however many columns you have. So in order to implement this model, we first just call the support vector classifier as in sklearn's documentation, and then we'll pass this argument where we set the kernel to linear. This isn't necessary to be done, the model will still work without it, but I just thought I would showcase that you can do it. You then fit the model to your trained data, which is really important. It has to be your trained data because that's what we're training the classifier on. And because this is a supervised learning model, we do need the y values for this to work. So after that, your model is already trained and you're now ready to predict some values. So we set the prediction variable to a prediction of the test values. So now we'll have what the machine learning algorithm classifier thinks, and we can compare that to the actual values. And we can compute how accurate our model is by computing an accuracy score, which will just take a percentage of the predictions that we got correct and display it. So as you can see, we got 100% accuracy, which is really good. So let's see what happens when we change the kernel to a different value. As you can see, our accuracy has decreased due to the parameters that we pass in. So this is just to show that parameters definitely can make a difference in your algorithm, and that you should work with parameters and try to fine-tune them so that you can get the best accuracy whenever you're doing machine learning. And this can also depend on your data split. So if I had a different split of data, or a different 80% as my train and different 20% as my test, this could have a different output. So it's a little bit random in that aspect. The next classifier that we're going to be using is a decision tree, which is something that some people might be familiar with already. So as you can see, the code is very similar to the code up above, with the only difference really being this line of code calling the decision tree classifier as opposed to the SVC classifier. I feel like this will be easier to explain once we can visualize it. But for now, you can see that the accuracy is 93%. So as you can see, this is the decision tree that the classifier makes. So a decision tree is basically done by taking a certain value and then comparing it. So this is saying if the petal length is less than 2.35, then it's likely that the value will be 0, because 36 of the values are 0. And if it's not, then it will go on to make another decision. And it'll keep on doing that until you've classified all of the values. And the next model that we're going to be using is k-means clustering. And this is the only unsupervised model that we're going to be using today. So as you can see in this graph, we have 3 distinct clusters of data, or groups of data. To the human eye, this is very easy to see. So we'll see how we can train a machine learning algorithm to also spot this and to tell that there are 3 groups of data. So first, we do have to tell the algorithm that there are 3 groups, and when we do this, it will put in 3 centroids, things called centroids, into the data randomly. So the data points that are closest to this centroid, to each centroid, will be assigned to that centroid. So as you can see, all of the yellow data sets are assigned to the yellow centroid, and the red data sets are assigned to the red centroid, so on and so forth. So the goal is that this yellow centroid will classify all of these values as yellow, and the red will classify all these values as red, and this blue will classify all these values as blue. So how does it do that? So first, this centroid will move to the center of all of the values that it predicted as yellow. So this will move up here, and then this red will move to the center of the values that it predicted as red, so it'll move here, and this blue will move further to the left. And then after that, it will recompute which values are closest to it, and it will reassign the data. So as you can see in this graph, all of the yellow values are now here, although there is one mistake here. All the blue values are here, and the red values are here. And it will keep doing this again and again until the centroids converge to a single point each. So as you can see by the end, it classifies all the groups correctly. But k-means clustering can definitely have its shortcomings, one of them being that depending on where the centroids are initialized, or the starting point of each centroid, can lead to different outcomes or different clusters. So oftentimes it's beneficial to repeat the clustering just in case you get a better value. So that's why I'm iterating 20 times, and I'm breaking if the accuracy is above 80%, because that's what I deem as a good accuracy, although this is completely up to you. So as you can see, we finally got 90% accuracy after 2 iterations. And so to visualize the final clusters that we got, we can just graph them. So this is what we classified it as, and this is the ground truth. So as you can see, there are some values that we got wrong, like this value here according to this value, and then this value corresponding to some value over here. But in general, you can see that the pattern that we got is pretty similar. So it is good for a general means of classification. So I hope you now have a few tools that can let you do some machine learning algorithms on your own, and thank you for watching.